All right, guys, let's take a look now at the 8.1b worksheet. And in this one, this is a little bit more like what we're kind of supposed to be doing with an 8.1. We've been given a right triangle in each one of these cases. Two sides have been given to us, 8 centimeters and 10 centimeters. We've got to find the third. So this right here, guys, is the Pythagorean theorem. In a right triangle, when two sides are given, we're going to use the Pythagorean theorem. And you guys know, if you watch the other video, that I always like to write legs squared plus legs squared equals hypotenuse squared rather than a squared plus b squared equals c squared. Helps me stay a little bit more organized. Okay, so I'm looking for the length of one of my legs, and that's going to be x here. You can do the 8 first, but I like the variable first. So x is one of our legs. The other leg here is 8, and the hypotenuse, remember guys, the hypotenuse is defined as being across from the right angle. I usually like to put a box around that. Our hypotenuse is 10, so we're going to put that there on the right-hand side. All right, next step, we simplify what we can. Can't do anything with x squared. The 8 squared becomes a 64, and the 10 squared is going to be a 100. Okay, to solve this equation, we're going to subtract a 64 from both sides of the equation. Those two cancel out, and we're going to get an x squared is equal to, and 100 minus 64 is 36. Last thing we need to do here, ask yourself what's being done to x. It's being squared. What will undo that? A square root, and we do that on both the left and the right. The square and the square root cancel each other out, and we end up with x equals, and the square root of 36 just ends up being 6. Okay, and that was the answer that we were looking for. A really good thing to do at the end of a problem like this is just to make sure of one quick thing. We know for a fact that the hypotenuse has to be the longest side in any right triangle. So for the value that we just came up with for x, we need to make sure that that value is smaller than the hypotenuse of 10. So that doesn't guarantee that I got the problem right, but at least makes me think that I haven't made a silly mistake. Now, if I got something like x is equal to 13, for example, I would know that that answer had to be wrong because the hypotenuse has to be the longest side. X would have to be smaller than 10, not bigger than 10. So keep that in mind. Okay, let's move on to number 5 here. And the direction shifted just a little bit right here, and they told you to express your answer in simple radical form, not as a decimal. So let's get rolling on this one. Again, it's a right triangle, and we were given the lengths of two sides, and we got to find the third. So that tells me that we're going to be using the Pythagorean theorem again. Leg squared plus leg squared equals hypotenuse squared. Here's my right angle, so my legs are x and 11, and the hypotenuse, which is always across from that, is 16. So let's fill in what we know. One of the legs is x, and we square it. The other leg is 11, and we square that, and the hypotenuse is 16, and sure enough, that gets squared as well. Next step down, simplify what you can. X squared plus 121 is equal to the square of 16, which is 256. We're going to subtract that 121 from both sides. Those two cancel, and we now have x squared is equal to, looks like it is going to be 135 now on the right-hand side, and we undo this square by taking a square root of the left, and we balance that with a square root on the right. The square and the square root cancel, so we're going to get x equals. And now for the square root of 135, we're going to go back to our list of perfect squares. I'd cut that 135 in half, and I would get 67.5. The first perfect square smaller than that is 64, and just making my list backwards now, 7 squared is 49, 6 squared is 36, 5 squared is 25, 16, 9, and 4. Let's start with the 64 here and see if we can't find a number that goes evenly into 135. Now, I said something like this before. This is an odd radicand. Even numbers will never go into odd numbers. So I can automatically cross out 64, 36, 16, and 4. There's no way that an even number divides evenly into an odd. So we're going to try 135 divided by 49. That one didn't work. 135 divided by 25, that one doesn't work either. 135 divided by 9 is our last chance, and this one works out. The 9 goes evenly into 135 15 times. So, second to last step, we split this up into the square root of 9 multiplied by the square root of 15, and this square root of 9 can be evaluated. The square root of 9 is 3, and the root 15 just tags along. So there's our answer right there, guys. X was equal to 3 times the square root of 15. Okay, that was number 5. Let's take a look at number 9. I wanted to do one like this with you guys because it does something that we hadn't seen before in our notes in the video here. So once again, right triangle, two sides are known. So we're going to write leg squared plus leg squared is equal to hypotenuse squared. Fill in what you know. Our legs are 8 and x. And the hypotenuse right over here is weird now. This number is presented to you with a radical as the square root of 226. So one of our legs is x, and we'll square that. The other leg is 8, and we'll square that. And here's where it gets weird. The hypotenuse is the square root of 226. That's the length of the hypotenuse, but we now need to square that. And something weird happens here in just a second. Okay, next line down. We're at an x squared plus the 8 squared is going to be a 64. And now on the right side, I'm hoping you guys see this because we've been doing it on the last couple problems. We're taking a square root and squaring it. Well, the square and the square root cancel each other out, leaving us with just our radicand of 226. So I don't expect you guys to like problems like this where they give you a radical, but in a way, it's actually easier than what we were dealing with before because once you square it, the square root just drops out. Okay, we're now going to subtract a 64 from both sides, and we're going to get an x squared is equal to 226 minus 64 is going to leave us with 162. And now we will take the square root of both sides and see what we get. The square and the square root cancel, and we just get an x. As for the square root of 162, this was the trick I gave you guys a while ago. Take that radicand, divide it by 2, and see where that gets you. That gets you 81 in this case. And boy, we got really lucky. 81 is a perfect square, so I don't have to look at any other numbers. I found what I was looking for right away. 81 times 2 takes the place of the 162. So we now split it. X is equal to the square root of 81 multiplied by the square root of 2, and the square root of 81 can be evaluated to 9. And the square root of 2 just tags along, so we end up with 9 root 2. Something I think I forgot to do on the last problem, our units here, everything was in meters. So x is equal to 9 root 2 meters. Okay, that was number 9. So that's what you do when you're given a radical there. And then let's talk about this one. The directions changed on 13 through 16. We're no longer finding the missing side because they already gave us all 3 sides. But we've got to state if each triangle is acute, obtuse, or right. In our notes, everybody, the word that we used right here was classify. So this is using theorem 8.2, if I'm not mistaken, which is the converse of the Pythagorean theorem. And if you watched the video notes, you know what to do here. If you didn't, you probably want to go back and check that right now, everybody, because it's a lot for me to explain within the context of this problem. But what we do is we kind of reverse the Pythagorean theorem. We start with c squared. Then I like to put kind of an empty box and then a squared plus b squared over here on the right. Now we fill in what we know. We shouldn't use the words leg and hypotenuse right now because we don't actually know if this is a right triangle or if they actually have a leg or a hypotenuse. But what we should know is that the C over here on the left side would always represent the longest side of the triangle. The 5 and the 12, the shorter sides, will be the A and the B, but the C needs to be the longest side. So we're going to put a 15 squared right here. I'll keep that empty box here. And the A and the B, it doesn't matter which is which, but usually I like A to be the smaller one and b to be the middle side. And now we simplify what we can. On the left side, 15 squared is going to be 225. Compared to, now this, you can go ahead and put all of that in your calculator at once. 5 squared plus 12 squared is going to get you, if I'm not mistaken, 169. Let me double check that. I would hate to lie to you guys. Yeah, 169 is right. Now, what we can see right here, everybody, is that the two numbers we came up with on the left and the right are not equal to each other. If they were equal, this would be a right triangle because the Pythagorean theorem would hold in reverse. But as it is now, they're not equal. 225 is greater than 169. That means, going up now, that c squared is greater than a squared plus b squared. And when you see the greater than, we think bigger. That means that this triangle here is an obtuse triangle. Okay, if c squared is greater than a squared plus b squared, it's obtuse. Real quickly, if they were equal to each other, your triangle would be right. And if c squared was less than a squared plus b squared, your triangle would be acute. Okay, so that's the way to do number 14. So if you go back and do 13, 15, and 16, you'll get a good sampling for all of the different things that can happen there. Okay, so that's all we were going to do for the 8.1b worksheet for now, but if you have any more questions, post them in comments, please.